Okay, we're going to do more practice. We're going to do problem 3.5 and problem 3.6. So in problem 3.5, these forces are concurrent. And remember, if the forces are concurrent, we can use particle equilibrium. Just look at point O as the particle. And also, we're given that this angle theta here is 90 degrees. So that's nice. They want to find F and T. So as I mentioned before, when we have 2D particle equilibrium, we'll end up with two equations. So we'll have two equations, and the two unknowns are F and T. In all these problems, there's always two equations so we can solve. Which brings me to one concern. When Dr. Erickson was substituting, apparently some of you had trouble solving two equations for two unknowns. So we'll go over that in class as well. But let's start this problem, and as always, you start with drawing a free body diagram. So here we go. I'm going to draw this loop here. I'm going to draw everything in the loop first. Okay, so I'm going to paste in here my crude sketch of what was in there. Okay, I could have actually cut and pasted the actual picture, but to make it look like what you're doing. There are no gravity forces, so there's no forces within the loop. Now let's draw in everything we've carefully cut through. So we've cut through that line. We've cut through this F, which is at 3 to 4. Okay, and then we've cut through this T, and it's at 90 degrees to the F. And I don't know if you know this, but when angles are 90 degrees to each other, you just flip the X and the Y. So 3x, 4y turns into 4x and 3y. So once you've got the free body diagram drawn, all you need to do is write sum fx equals 0, and then sum fy equals 0. You'll have two equations, you'll have two unknowns, and then just solve. So let me write out sum fx equals 0. The 9 is in the y direction, so there's no component. The F has an x component of 3/5 F, and it's going to the left, so I set to the right positive, so that's negative. And the T has a 4/5 in the x, positive, so I'll set that equal to 0. Sum Fy equals to 0. I'm going to take up as positive. That's typically what I do. That 9 is going up. F is pointing down. Its y component is 4/5 F. And the T is also pointing down. So minus 3/5 T all equals to 0. So all I'm going to do now is just rewrite. I'm going to call this equation 1 and equation 2. I'm going to rewrite those two equations and all the unknowns on the left-hand side, all the knowns on the right-hand side. And I'll also keep the order of the unknowns the same in each of the equations. So equation 1 becomes minus 3/5 F plus 4/5 T equals 0. And equation 2 becomes minus 4/5 F minus 3/5 T equals minus 9. So that's now equations 1 and 2. So you can solve these any way you want. I can think of 3 ways off the top of my head. 1, put it in your calculator. 2, solve equation 1 for, let's say, F. Then put that into equation 2 and solve equation 2 for T. Or what I'm going to do right here is I'm going to multiply equation 2 by something that will make one of the terms equal to the term in equation 1, and I'm going to subtract the equations. What I want to do is turn this 3/5 here into 4/5. What I'm going to do is multiply equation 2. I'm going to multiply this whole equation times 4/3. Because 4/3 times 3/5 will be 4/5. So I'm going to multiply that equation by 4/3. So the new equation 2, multiplying both sides by 4/3, is minus 16 over 15 minus 4 over 5. That's what we wanted, T. equals minus 4/3 of 9 is 12. We'll call that equation 2 star. Now all I'm going to do is add equation 1 and 2 star. That comes out to minus 3/5 f minus 16/15 f plus 4/5 t minus 4/5 t equals 0. That was the whole point. Equals 0 plus minus 12. We can now solve this equation for f. 3/5 is 9/15 f minus 16/15 f equals minus 12, or minus 25 over 15 f equals minus 12, and finally f equals 7.2 kilonewtons. Now all I'm going to do is put this back into equation 1 and solve for t. So minus 3/5 f plus 4/5 t equals 0, or t equals, well, let's see, 3/4 f equals 3/4 times 7.2 equals 5.4 kilonewtons. Of course, if this were a real homework, I'd do it much neater, and then I would box the answers. So here are the answers. F is 7.2 kilonewtons in compression, and T is 5 kilonewtons in tension. And what I mean by that, if you look at this picture here, you can see that F is pushing into the joint, so it's compressing the joint, and T is pulling away from the joint, or it's in tension from the joint. This is problem 3.6, same picture as 3.5. This time we're given that F is 8 kilonewtons, and they want us to find T and theta. So again, there are two unknowns, this time T and theta, because there are two equations. I know I'm going to have to take the x and y components of T, and using theta will be cumbersome. So what I'm going to do is I'm going to say, let this angle here be alpha. After I solve for alpha, I can get theta, knowing that the angle to B is at a 345. Okay, we're just going to do the same thing again. We're going to take sum of fx equals 0, then sum of fy equals 0. We'll have two equations, two unknowns, and do a little algebra to solve. Hopefully this is starting to get boring for you. That would mean you understand how to do it. We'll start with sum fx equals 0. Sum fx equals 0. The y has no x component. The 9 kilonewton has no x component. That force F8, it has an x component of 4/5 times 8. And it's going to the left, so that'll be negative. The t has a component of t cosine alpha in the positive x direction, and that will all equal 0. We also have sum fy equals 0. I'm going to take up as positive. I took right as positive for x. Up is positive for y. That 9 kilonewtons is going up. F has a y component of 3/5 times 8, and it's going down, so I made it negative. The t has a y component of t sine alpha, and that happens to be going down, so again negative. That all equals 0. What I'm going to do is write equation 1, the x equation, and equation 2, the y equation, with all the unknowns on the left, all the knowns on the right, and I'll come right back. These two equations, they come out to be t cos alpha equals 6.4 and t sine alpha equals 4.2. That's a little hard to solve. You can't solve it in your calculator unless you got a fancy calculator. You can't add the equations to make one of them go away. I've done this enough where I know what to do. So what I'm going to do whenever you have a problem like this is I'm going to divide the equations, and when I divide the equations it will get rid of the t, and then I'll have tangent of alpha and I can solve for that. So I'm going to take equation 2 divided by equation 1 because I want sine over cosine to get tangent alpha. So I have t sine alpha over t cos alpha equals 4.2 divided by 6.4. And the t's will cancel out, so you get tangent alpha equals 0.6563. Taking the arctangent of that, I get alpha equals 33.27 degrees. We'll calculate theta later, but right now I want to solve for t. So I'm going to put this back into equation 1. So in equation 1 we had minus 4/5 times 8 plus t times cosine alpha, which is 33.27 degrees, equals 0. I'll solve for t and come back. T ends up being 7.65 kilonewtons. The last step is to figure out theta. We have this angle at 345 or 435, and we had alpha was 33.27, and theta is the sum of those two angles. So this angle here, beta, is 36.87 degrees. Sometimes students, they see the 345, they get confused. They think 345 is 30 degrees. It's not. 345 is 36.87 degrees. So theta is the total of those two, and that equals 70.1 degrees. The final answer is T equals 7.65 kilonewtons, and theta is 70.1 degrees, and that T is in tension.